scenario as well into the whole story. First being the larger attack surface to start with. It's no more about having a monolith application that has a controlled access from a very specific UI, which forms the front end of the application, goes hits a app server, and which has a very secure connection just to be able to talk to a single database and stuff like that. That does not exist anymore, as we'll get to see. Enterprises are using over 75 plus solutions to secure hybrid cloud. This is not coming directly from us, it's from a statistic. Happy to provide the reference there. So there are between siloed point solutions and overall portfolio sec. It's just seeming like you need a whole bunch of different kind of solutions to be able to secure hybrid cloud when it comes to different kind of workloads or different kind of cloud solutions and so on. And of course, applications and APIs are the latest targets, as we've all seen from some of these trends. So this is talking really about going from a traditional monolith kind of application where things were hosted behind a data center. You had a specific app and a database which only spoke to just each other. You did not have third-party interactions. You did not have like 5 different types of clients or any other kind of in-between interactions to be able to directly access the data. So then came a concept of mostly something like a private cloud powered largely by VMs and containers, where you still had your data center. Things were running on VMs behind a hypervisor, or you had more containers behind these VMs, which kind of hosted either similar applications or more modern API-based microservices, which were at the end of the day powering these kind of applications. So you now have the ability to support multiple clients, access databases in the way it's supposed to be able to, and return, say, JSON or XML outputs that could be consumed in any form or themed in any form based on the user interface. And then, between private and public cloud, there is not exactly like much of a difference in terms of application architecture. You were able to run all this without the management hassle of running a data center, partly, and from there came platform as a service kind of offerings, and serverless can be compared to one of those. So you don't have a dedicated server that is waiting there to serve requests anymore. You have Lambda functions that could go all the way from cold start to serving a request in less than a few seconds, so much that a user will not be able to see what's going on. So you only pay literally for what you use, and to be able to go from an always-on server that is serving requests, irrespective of what the traffic volume is, to be able to go literally from 0 all the way to 100, even without any cold start. So let's just say 2 days in a month, you get all the requests, and afterwards you don't get anything at all. You pay nothing for the rest of the 28 days. This used to be the case even with, for example, EC2, but you had to manually turn off instances and stuff like that. Both with serverless functions and serverless databases, that is not the case. Like, it spins up the moment a request is being made. So that kind of brings us to the enterprise evolution to really go from where we were on monoliths. It just changes both on the infrastructure side of things and also to be able to go from application architectures. We now have APIs and microservices. Databases are now structured, unstructured. You have data lakes, and we even have serverless databases such as, say, Error or Postgres, which now support serverless. And there are physical servers which move to containers and also serverless. So your compute is now serverless. You have applications that are able to take advantage of this compute. And obviously not really running data centers anymore in a shared multi-tenanted model. So today we're going to talk about the compute engines, specifically about serverless functions and what it really means for security. So speaking of the shift to serverless and what has been the motivation points in here, we've spoken about some of these. First is event-driven computation. This is really powerful for somebody that used to be a developer before. to really say that, hey, you now can do, let's say an event happened within my infrastructure. Somebody put a file in an S3 bucket. You need to take it in line and process it. You can do that directly with the serverless function. You don't need a file watcher or something of that sort that's going and looking for basically watching a directory, scanning for files every second to be able to do that. Like, you have the event directly coming to you, and you simply execute stuff based on what the event was, and that's about it. This is not just for files; it's for API gateway, it's for Kinesis streams, like any kind of front end points that entry points that AWS supports today. No service supervision. Again, if there are no requests, zero requests, you literally pay $0. If you have a few requests, you pay for one, and then like from there, the usual cloud scaling model applies. This really supports for modular design patterns, and we're going to talk a little bit more about this as well in security context when we say what this really means for development. So we went from monoliths to microservices, which really made things modular as well. Like, so the microservice was now doing its own thing, taking a very fixed set of inputs and returning what it's supposed to do, and does not need to know the broader context. So you could treat the microservice more like a black box that's really just taking in this kind of request, processing something, and then this is the response. So whoever wanted to consume it, irrespective of the caller, could just go ahead and use it. Serverless takes it one step even further, where there is not like a binding thing that is calling these microservices. It could be events that are calling serverless functions, for example. So the caller does not really have to know much about the downstream context. It would simply go do things the way it's supposed to do. Go write it to a message queue or put a file in a particular bucket, and that's it. Like, that particular service's job is done. And once you get the event that, hey, a new file has been put in this particular bucket in this location, the next serverless function basically picks up the relay from there and starts running. So it really supports for a different level of modular design pattern, like a step further from what microservices afforded us to do. And last is, of course, millisecond-based billing. Most serverless functions, based on some of the statistics that we see, run for like 100 milliseconds or less. Some of the processing functions run for like about maybe a second. And that is it. Like, you literally pay by the millisecond that you use and per request model in the order of fourth degree of cents or something of that sort. So all of this is really powering the shift to serverless. One of the things we wanted to know was where are you with your serverless journey, and what are the kind of scenarios that you're using serverless for today? Are you using it for, say, a powering engine behind an API gateway to be able to power your APIs? Or are you, say, using it for log processing? Or are you using it for transformations of stream data? There are multiple different scenarios. Every time we talk to a customer, they surprise us with a new use case for using serverless. It's just, I think, the power of the platform. We're looking forward to hear what your thoughts are on there. Like, please do let us know in the chat, what are you specifically looking at serverless for, and what attracts you there. Okay, are there any questions at this point to be able to take?
No, I think you're good to start your demo. Everyone, awesome. I will take your questions, and then maybe we'll hold them until Raj finishes the first section of the demo. Is that okay, Raj?
Yeah, perfect. That sounds good. So yeah, we have some more content, and then we could get into the demo as well.
Super.
Okay. Yeah, so speaking of challenge again, we are talking about what it means to secure serverless functions. Purely from a security standpoint. This is all great for development and the modular architecture, and for DevOps teams because they don't have to provision anything, and for even finance teams because they're paying by the millisecond for brand new services. Like, let's say you're testing a beta and you don't know how many customers are going to show up. Like, you don't need to do anything. Like, just use it. If you use it on serverless functions, you're probably paying by the cents for it. So this is great. But to understand what it means from a security perspective, there are just multiple challenges. The first one is the code sprawl. We spoke a lot about this in the previous slides as well. That applications really moved from being boundaried, perimetered, where you had a user that had a specific web app which interacted with, say, a backend, And this was all like, there was only one entry point to the application. And we went from there to microservices, where we said, okay, fine, there are now 20 different microservices which are all interacting with each other. They are no more behind just your organization's boundaries. They are often connected to third parties. They are also behind, say, some kind of services that are consuming your APIs. Let's say you opened up an API in the marketplace, and which is also like consumed in its own, or you have a vendor that is trying to pull some information from you because you're the one that holds it even in line. So all of this just removes the boundary restriction from a security perspective. So for more traditional applications, it was super easy to put a WAF or any kind of firewall around this. That totally makes sense, and we have the best WAF product out there, which has a pretty significant market presence. The architecture changes certain things. I mean, you could still use, say, a WAF in front of an API gateway or something similar in this scenario, but there is no guarantee that all the traffic is flowing through from the outside to inside. Like you could have, for example, an internal service that is calling the same kind of microservice that's being used by within an application. So that's the additional challenge that microservices introduces, for which, again, WAF has done a pretty good job by the kind of updates that they've done and so on. Again, like serverless just takes this a little bit further, where you don't just have services anymore that are calling each other. You have resources that are calling services. Say a Lambda function could be triggered through an API gateway, an SQSQ, or because of a publish event in SNS or something of that sort. It's just, so you're now treating resources and compute engines alike, which kind of makes serverless a little bit more complex, as much as it brings the event-driven programming kind of interface. So the code sprawl is really the challenge here when it comes to serverless, and from a security perspective. Like, so it just flows all over the place. So where do I start from protecting is a question that comes. The second is the event-driven surface area. Again, increasing surface area leads rise to new attack vectors, specifically on same-site request forgery, or SSRF as we call it. So let's say, for example, there's a website which is public facing. It is putting in content into, say, an S3 bucket. Like it's retrieving a file and putting it in an S3 bucket to the Lambda function that is processing this. And remember, we said one of the advantages of Lambda is that it doesn't need to know the entire context. It's just doing its little thing. So this function does not have context that this is a file that actually came from a public-facing website. We could build it like through additional metadata or tagging or something of that sort. But just based on how things are, let's just say this is a file that is now an internal resource within your environment. You can protect the bucket in any way you want, but it was ultimately written to by a web application which had public access. So the Lambda could unsuspectingly start processing it to be able to give, to the Lambda, this is basically an internal resource. So there's not much security built into it, or to be able to validate the input and stuff like that. If the file itself was malicious, you could now trigger, send the same malicious attack downstream in the attack surface. So those are the kind of new attack vectors that we see is coming from. And again, injections and remote code execution is not new at all. But the kind of injections that you could do, given that you now have the power for being able to go from events to compute, is actually much higher. The third challenge that we're going to talk about is to be able to use the ability to use traditional tools. First, we already spoke about perimeter security. We don't have a defined perimeter in this case. And for example, with some of the SSRF attacks, the attack is actually originating, at least for the compute layer, from within your network. So that's one of the challenges behind using perimeter security for serverless. The second is observability tools. We've seen this come up a lot more recently. These are primarily focused on metrics for developers. which is great because they need to know how their performance is and how the serverless functions are performing. They can suggest you some cost optimizations based on runtimes and stuff like that. But they really provide metrics. That's kind of what it does. It's observability. They don't do security. They're not that effective in securing functions. The last is scanning tools. This was very powerful in more traditional development, where security teams were able to gate the code. So, say for example, a new release was like a 2-month release cycle, or even on a 30-day release cycle. There was some kind of a process or governance that you could put in front of it saying, hey, well, yeah, you need to pass this, go through your, SAS or DAS scans, help us with the report. We will identify vulnerabilities. You got to fix them so you can now release the piece of code. Now we're really talking about releasing multiple times a day. And with serverless functions, it's very decentralized. Like I could take something to production tomorrow. And yes, you could. I mean, there are tools that basically do this after the fact to be able to scan and say that, hey, these are public-facing serverless functions and stuff like that. But the power is really decentralized. Like nothing really stops people from taking something to production the way it is tomorrow. And really, with serverless, that's the speed at which your development teams should be running, anyways, because they picked serverless for the architectural flexibility and the modularity that it affords. If we use the same gating process that we use in traditional application, one of the biggest reasons why developers wanted to move to this goes away. So it fades some of the value for them. So what is effective, right? So that is when we thought about this problem, even from our own development teams. That is where we introduce Imperva serverless protection for AWS Lambda. So we could start with a quick demo and kind of go from, I'm going to go a little slow on this demo. Feel free to ask questions in chat as well. I will take them all at the end of the demo though, if it helps. So I'm going to start with a basic Lambda function that we could have based on how things are. So let me start from here, right? So it's a very simple, gullible Lambda function. We have something that is taking an input and running it in the command line. This is okay for simple command because it was trying to use it for ls. But nothing really changes somebody from using it for printing out the passwd file if they wanted to. So that's kind of the vulnerable Lambda function here. I wanted to start simple. We're going to see one more complex one right after this one. So going into onboarding a new account, this is basically our manager console. If once you log in the first time, you would be adding a new AWS account. You can create this through a CloudFormation template. You basically click on this. We would create the stack for you with the necessary access. We basically need Lambda read access to be able to do the discovery. So once you do the create stack part, it would show up in a way like this. So you can add multiple accounts. It would just show up in the scroll here. So you have the function, which region and kind of runtime. So we currently primarily support Python. We do have support for Node.js, which is coming pretty soon. And for if you have any other runtimes that you're most commonly using, please do let us know through chat, and we want to take that input back. So for most purposes, we support Python 3x and Node.js right now because from what we understand, over 70% of functions are developed in that. We could be totally wrong about it though. I have, for example, the test serverless function that we saw over here. You're able to add protections at the flip of a switch. So really, between adding your first account, doing this discovery scan, and to be able to associate the initial configuration or the beta, the test configuration that we give you for serverless function, and enabling this, all of it takes like less than 10 minutes overall to be able to get from 0 to getting your first function really working from here. So let's go to configurations. So this is kind of, and this is what I'm having right now is a starter config. It basically has a bunch of knobs and buttons that you could use to turn on or turn off security features. And also more customizations on, for example, where the logs need to go and stuff like that. So this is all general stuff. Let's just go into logging. We have events and severity. For example, obviously, if somebody's trying to do a command injection, that would be a severe event versus, say, something like a tautology, which you could kind of configure it to be slightly different. The same, we also have informational events that come through. Essentially, we are adding ourselves as a Lambda layer to be able to tell you what's going on within the function. So if you could log it to file. In this case, we've turned it off because we are going to write to CloudWatch. Whatever events that we see would go into CloudWatch, from which you can pump it to any other system of your choice, like any other SIM of your choice or any other platforms that you use. We've seen a lot of our customers use Splunk. So we do show a significant level of stack trace. So before I go into too much of these details, I just want to show what kind of controls are enabled, and we could probably do the revisit of this one as well. So you do have HTTP-based protections. This applies if your Lambda is behind, for example, an API gateway. So we could take and use some of the headers to be able to make decisions. So I do have command injection protection in monitor mode. So what this says is if any OS command that the Lambda function tries to execute, you could choose. I mean, we basically do a monitor, which means an event will be triggered when that happens. So to go from there to protect would basically mean it would be blocked and it throw a traceback, which can then be handled either at the API gateway level or even within your code to say that, hey, this is not an allowed action, just go revisit what's going on. And the next is path traversal protection. This is basically saying, it's not really supposed to be using paths beyond, say, an allowed set of paths, which makes sense. In this case, you could do a monitor. And for example, I'm using some image processing script on the other demo. So I've basically listed 3 particular specific paths to just go through whatever it's supposed to do. So everything else, if it's trying to access random paths, like say TMP or anything of that sort, we want to make sure we flag that one. And the other thing I want to highlight here is, as much as we say this is serverless for compute, it actually has an underlying server and with a file system and a Linux microkernel and everything of that sort. So it is susceptible to things like path traversal protection. It does have its own environment variables, which could be printed out, causing a significant security risk. Because invariably, if you're using Boto, you are going to have your secret key in the environment variable. So yeah, those are the right way to treat serverless, at least, is once the runtime starts, it's not very different from a traditional Linux microkernel environment. It's small with limited memory and it spins up and spins down. But while at the runtime, it's not a lot different in terms of file system to really be able to really distinguish it from a Linux environment. So I'm going to keep it back to disabled just for this function. SQL injection. So it's a very common type of attack where you're basically trying to either comment out the input that came in and add your own for whatever goals that you have, even without knowing too much of the metadata of the database. So in this case, I'm actually using Postgres for the other demo functions. I've just set it to the monitor mode. Again, this basically means an event will be triggered, but it'll still let the query execute the way it is. And again, this is a starter config. Like what we recommend is to, basically use something similar for the different classes of serverless functions that you would have. And really, it's not as hard as it sounds because we're going through a page of config. An average serverless function size is about 100 lines at max from what we've seen. So you really don't have much of a legit need to access, say, more than 5 command line resources or to call out random external URLs and stuff like that. There's also network activity protection. So for example, let's just say there's a SolarWinds kind of an attack where it's reaching out to command and control server. you could say that, hey, it cannot make any outbound calls, or at least at the very least, just log all the outbound calls that it makes. You do have allow lists here as well, including subnet masks that you can provide in case if it's within your own networks. Yes, you could turn on VPC-based protection for the Lambda itself, but invariably, doing a mass outbound restriction can be a bit of an issue because you're likely calling third-party APIs or something of that sort. So having a specific, just having the network activity mode, at least in monitor, even if you have it open, like for outbound calls to the internet, that is okay. We've seen most restrictions on the VPC to be on the inbound side, not that much on the outbound side. And we do have weak crypto protection as well, protection against older cryptographic algorithms. So I'm just going to leave. So these are the kind of configuration changes that you could make. So, and there are a master list of configurations. You could download this as a JSON file as well if it helps you to just manipulate this offline, which we don't recommend. We recommend using our interface for that because it's just much easier to use. So going into the function, you are able to associate a configuration to a particular, associate a function to a particular configuration. So in this case, I'm just gonna update this to serverless test. And I'm turning on protections here. As you can see, it's literally a flip of a button once you have the right config in place. And you can easily share configurations. The way we recommend as a starting point is anything API gateway based, you're likely going to have a separate configuration. Anything around file manipulation or log processing, say you're going to have a separate configuration. That can be a good starter to just get started with. So let's go into our vulnerable function in here. Looking at where our function lies, serverless demo 3.8. I'm just going to do a test event in here, which basically has, it's trying to execute ls. That's really what it's trying to do. It has a command I. So I'm going to do the test. So that says it succeeded, has some return values. It consumed about 1.8 ms and was about 400 something milliseconds. So let's go into the logs. So again, this is CloudWatch logs, which can be shipped into any forwarding SIM system of your choice. Let's pick the latest one. Yeah, so here we go. In this case, on the configuration, I had turned on dependency as well. So, and this is what we saw, for example, the severity of events. There's an informational event where it says, hey, you have 5 other dependencies within your application. In this case, it's referring to site packages. And then we have now, for example, date util and stuff like that. And any application, as we see, is going to have other types of dependencies. So this has S3 transfer, URL lib3, async IO. And we also have versions for a lot of these. Boto has 1.17 and stuff like that. This really goes into a vulnerability management program if you're able to, if you ship it to a SIM and use some of our existing dashboards to really say, hey, fine, I now have a vulnerability in this particular version of this library. How do I go about getting a catalog of all applications that use this to fix it? So here we go with the dependency. The other thing I want to mention here is this is runtime dependency. So if you, for example, have unused imports and stuff like that, it would not be classified in here. So you have a lesser backlog of things to work with. And it was waiting for an event. It did get an event. So it says this was a high severity event, but was monitored. So the action was actually allowed. What happened was a command injection. It ran an executable ls. I purposely did not log the environment variable. You could do this as well in the configuration. You could specify which variables did you want to log. The only caution I would say is a lot of sensitive information gets logged by default on the environment variable. So for example, AWS secret key and stuff like that. In this case, we chose not to log it. So going from there to say where the working directory was, all Lambda functions get triggered by default from where task. It's running this particular function, lambda function.py. It talks about what the inbound parameters and the header request was from the API gateway. It really says what was the particular command that was executed, which is ls, and gives you the entire stack trace of what triggered that one. For example, in this case, the starting entry point obviously was the command helper function within our lambda function itself, which was in line 15, as it says. So this helps go back and mitigate some of these vulnerabilities, or you could even turn on protect if you have a longer vulnerability backlog to go fix. With the right policies, you can you basically buy more time to go patch some of these, which is where, for example, you cannot use a SAST or DAST to be able to go that fast in the level of release cycles that they're at. So this is an example lambda function that is basically just overtly performing command injection. You could say, hey, our developers are much better. They don't do something like this, which is very fair. But this is just an example. We wanted to show where to start. We're going to see another demo as well right after this, which is a more common scenario from what things can be. So,
Raj, do you want to take a couple of questions before you begin the next demo?
That's right.
Super. Okay, we got a couple for you, and forgive me if you've already answered them. First question is, in terms of the support roadmap, when or if do you think Java runtime for Lambda will be added?
Sorry, could you repeat that? Java runtime for Lambda?
Yeah, Java runtime.
Java runtime. Okay.
Yeah.
I'm not able to comment on a time at this point. This is a great question. We want to understand better the use case for Java, like just wanting to understand how they use it, which kind of frameworks and stuff like that. This would be a great session for setting up a follow-up conversation to understand where they are with Java. Just to give a reference, we basically pivoted our RASP solution to be able to use the same engine, the analyze engine for serverless functions here. And we did a lot of customizations to make this work with discovery and kind of the API. So we do support Java on our runtime security RASP offering today. So it'd be great to understand how they're using this for serverless and the kind of frameworks that they use. It's a good one for a follow-up conversation.
Maybe Camilo, this is something that you could pose in user voice, right, Raj? Is this the kind of question that we would want to see in user voice?
Absolutely.
So
That's right.
Yeah, you might head over to the user voice website and post that, and that way, if anyone feels the same way, we can certainly start collecting your information and using that as a feature request. We have one more question. Where do you configure Imperva or Brevity jar and config files?
So if you're used to more of the RASP kind of an interface, I see where that is coming from. And the difference between the traditional Brevity kind of RASP versus what we have on serverless is that the configurations are interactive. So any config change that you make here, for example, let's just say I want to now turn off dependencies. Let's say I do this, and then I perform a save application configuration. This will automatically update the configuration on the serverless function as well. In the traditional RASP world, you probably had to download a JSON and then copy paste it and stuff like that. You do not have to do any of this. This is interactive. So any function that now has the serverless test configuration will automatically have that setting applied. If I run the serverless demo 3.8 now again, you will not see the dependency events come through. Let's test that again. So this is cool. I don't know if this is the latest one. Let's run it again to make sure this is cool. Yep, let's go into the logs. Yep, so you have a configuration stats event. You don't have the set of dependency events that we saw. And at the end of it, you do see the command I event as well here. So the configuration is interactive. So as long as you've made the change in the UI, any function that has this config associated with it will get updated automatically, dynamically.
HJ, that give you the answer you needed? We have one more question, Raj. We have time?
Yep.
How do you establish the connectivity between Lambda and the RASP manager?
Great question. So we have a microservice architecture that is running within RASP Manager that basically has this connectivity. You do have an API key now, which kind of gets this. I mean, at the risk of this kind of my public API key anyway. So we have this to be able to securely interact between the RASP manager and the Lambda console.
Okay, got one more question for you. I think this is a follow-up. Camilo asked earlier about the roadmap. Here, the question is there an API to make the configuration?
I'm not sure I got the question.
I'm not sure either. Camila, do you mean, is that a follow-up to the previous question about configuration?
No, sorry. It's if we could make the configuration of RASP to serverless with an API without going to this web page to make the configuration.
God, I see what you're saying. No, so today there is not an API-based interface to create the configuration itself. Mostly because what we've seen is, since this is free-form JSON and a lot of this does not apply to some of the different kind of functions, we've added a lot of validators when you try to make edits on the configuration here. That's one of the reasons we don't have the API to be able to upload any JSON into a config in here. Making this is the primary way out there. Having said that, you could potentially use Terraform scripts for the invoke or the association part here. You could, if you have the configuration already, you can associate a function to a configuration and enable RASP. This part of the activity, you can potentially do this with Terraform scripts. We've seen some of our customers do that.
Raja, I have one more question, but I'm a little bit concerned about time. Do you have time, or do you want to push on to the next demo?
We have, what, 20 more minutes to go, right? Yeah, I can take one more question.
Okay, super. This is HJ. Thanks, HJ, for your questions. So he's asking, now that you have API keys, do you plan to implement MFA on RASP Manager?
That's a great question. So we do have MFA on RASP Manager even today. You could, for example, configure Google Authenticator along with your password for RASP Manager. If they meant, for example, MFA for usage of APIs, I'm not sure if that was the question. We do have MFA today for the regular logging and kind of functionality today.
HJ, does that give you the answer you need?
Yep, and sorry to interrupt you, but I have one more question, Raja.
Oh yeah. Sure.
Yep. So this is only available for APIs function like interactive one, or this can be available for the normal web servers architecture, 3-tier architecture as well?
So for the normal 3-tier architecture, you could use our traditional RASP solution, which works slightly similarly, just that the process is a little bit more manual. Obviously, we can't scan for all the applications that you have and show it in a list like this, or to be able to remotely update configuration and stuff like that. So that would be the major change. But otherwise, functionality-wise, to be able to protect from Command I or Network I, you get a similar functionality from our standalone RASP solution for traditional apps.
Okay, got it. Thank you.
Thanks, AJ.
Okay, let's switch back and we can probably take more questions if I'm done with the demo quicker. So that's about Imperva serverless protection. We are able to use this to protect, again, serverless top 10 vulnerabilities, which is basically a derivation of OWASP top 10 for web applications. This currently integrates with Imperva Sonar, AWS, we basically write events to AWS CloudWatch, which can then be forwarded to any SIM of your choice. Most of them have CloudWatch forwarders that you could just directly use. So again, I'm not going to read out each of these. Most of this is OWASP top 10 coverage. Some of them in a little bit more detail. For example, injections is one particular coverage in OWASP top 10, which we've basically expanded to say what kind of injections we protect against, the kind of attacks, and also weaknesses when it comes to serverless protection. So this is kind of a schematic of how and where we embed ourselves, and to be able to see what we saw. You have a thread that's outside the network. Let's just say there's some thread and there's also some malicious traffic that's coming in. You have, say, a good traffic that is going by API gateway. So somebody's calling an API to either, like, for example, get to just retrieve a piece of data. You have a Lambda function that is processing what's coming in the API gateway to be able to query from the database and then respond appropriately with an API response, typically a JSON. So let's just say this was legit traffic and this was not. There was, say, a malicious file upload that's going to S3, which in itself is calling Lambda. So what the Imperva serverless protection layer, we've basically attached ourselves to the Lambda through something called a Lambda layer. It writes to CloudWatch the event itself, and if you had blocked it, it would just prevent the execution from happening. The event would trigger, but it would not do what the malicious activity that was supposed to be. It'll log it to CloudWatch, which in turn can go into the security platforms, in this case, Imperva Sonar, as we say. So now goes our second demo, where we're going to talk about a slightly sophisticated mechanism where you have, for example, a traditional website used in combination with Lambda. So you have an awkward file uploader, which we're going to see. To go from there to S3, all it does is basically show your web UI to be able to upload a file to an S3 bucket. Once the execution is there, once you have a Lambda function that is basically triggered on the event of a file put into a particular S3 bucket, to be able to go from there to query an RDS. In this case, let's just assume it's a image sharing service. And every time somebody uploads a file, just to tag it to a particular user ID, you upload it with a metadata or EXIF data within the image itself saying, hey, this file belongs to this particular user ID, which is great. So now what your Lambda function does is to scan a database, query a database for who's the user against the user ID, and associate the username to another parameter within the EXIF data. That's all our Lambda function is doing here. So we're going to see how a particular vulnerability can creep into something like this. So with the Imperva serverless protection layer, you basically block that kind of attack from happening and to be able to write it to CloudWatch. A simple example, as we're going to see, is user ID should typically be like a number or something of that sort, like say 101 is the user ID. What our Lambda function does is to query a database saying, hey, give me username for where the user ID is 101. And to basically embed that back into the image to put into another S3 bucket. So the thing is not really coming from somewhere outside. It's really a file from within your environment. So the Lambda does not really do much of error handling or anything of that sort, which in turn can be available for retrieval. The processed image can be available for retrieval in this case, is the thesis here. So let's go see how that works. So I have a particular function in here, which is called EXIF test. EXIF processor. All it does is, and again, it's a huge piece of code, so it's not showing up here, mostly including the dependencies and stuff like that. So, but we just saw what it does. Let's just try and execute this. For which I have the awkward file uploader. Basically, this is the more traditional web application that we saw. It's just running behind an Apache web server that is an always on. So you have, for example, say this user ID image, and then you have a malicious image. Let's just go see what these images actually have before we upload this, right? So this is our image with the user ID. This is a random anything on the web to just see EXIF data. Let's just go to see this. I mean, EXIF data typically has where the photo was taken and stuff like that, and has a user comment field, which is traditionally used for some kind of data processing like this. So the user comment is a JSONized string, which has something called user ID and has a plain text field, which is 1. great. So now what my function is supposed to do is to look for this user ID from this image and query the database and return back, who the particular user was. Which it sounds great. Like in a potential way in which this can be manipulated, let's go see what's going on in here. Let's just do the malicious image. I'm going to do an upload of this one. Let's just see what our malicious user is trying to do. Just like a classic SQL injection that is passed in a web interface, they now have something like this. User ID is equal to 1, or, and then they have a tautology, or 1 is equal to 1. If you're aware of SQL injection and any other web application, this would typically be passed in, say, a text box or something of that sort. And you could have layers that would catch them, like, for example, signatures or rules within your firewall to be able to get it based on you processing the get or post parameters within those forms. That was simple and straightforward, but this is a normal looking image. Like, until you go and scan for the EXIF data, you really don't see this. And most traditional tools do not do that. That's what makes serverless. And think of this as anything else that you would process with Lambda, like, say, a resume processing engine, which has malicious XML or malformed XML, for example. The story is not very different. So here, the attacker is basically trying to manipulate this user comment with just saying 1 or 1 is equal to 1. In the interest of time, I'm just going to process the malicious image directly with our awkward file uploader just to see what's happening. So we have this uploaded. It basically takes the uploaded image and puts it into an S3 bucket. That's really all it does. Let's go to our S3 bucket to see what's going on in here. I'm going to just pause screen sharing for a moment to switch S3 buckets. Give me a second, so I'm not showing all the details of the S3 bucket itself. Yeah. So I have another S3 bucket called EXIF test, right? This basically has the malicious image that has kind of gotten into this. This is our processed malicious image, basically. Let's go try and see what this looks like, right? Let's see what our malicious user managed to do by uploading this kind of an image. So I do have the recently downloaded malicious image, which I'm going to upload. Malicious image underscore revised is the name of it. So let's change that. Yeah, let's go see what this has on user data. It was really supposed to take the particular 1 as a key string to say that, hey, this is now going to be 1, my name, which was the username that it queried the database from. Instead, what happened was, since the tautology came into the database, it basically dumped the entire database. Right? You now have a list of all the users and their user IDs, which can be potentially used for any kind of manipulation. So you have 2, and then the username Peter, 3, who's a hacker, and 4 and on. Like, this is basically the dump of all the 4 users that's in the database, in our test database. The real use case would have been just to say that, hey, this is just going to be 1, Rajaram. Let's just go in to see where the logs lie and how are we doing this. This is our older function. Just seeing this is also our older function. This is also our older function. Let's just go see what we have here. This is our EXIF processor, just going and seeing where we are, right? So this is the input that it got. User ID is 1 or 1 is equal to 1. You do have this flagged. And remember, in our configuration, we allowed it to go. We put it all in monitor mode. So this went through fine, which is why you actually see the processed EXIF with the data leakage that happened. It's really doing a query such that, it's select user ID, username from users where user ID is equal to 1 or 1 is equal to 1. So the where clause gets overridden. It's really talking about, select all username and user ID from the entire table. And it kind of goes there and does the whole thing. But having RASP in the monitor mode really gets it to work to flag the event at the very least. So you could now go a step further and change this to protect mode. I'm using the same configuration across both the functions, which is okay too. I'm just going to say anything on SQLite, just switch to protect, and I'm going to block these kind of queries. Let's say there's an application configuration. Let's try our malicious image once again. There we go. I'm going to pause the screen 1 second to be able to go to the S3 bucket again. Sorry. So here's what I have. This is again the set of events that we saw previously. Let's just go into the logs itself, get the latest one. We have a configuration that says this command injection happened. Okay, this was the serverless demo. Let's go into the EXIF processor. Yep. So in this case, we see that this action was blocked on SQLite. So our new image on the EXIF test write bucket would not really have the kind of data that it exfiltrated previously. And we still have the old one. We still have the old file that's out there, but the execution itself would not have completed, as you can see here. It failed, and it says query blocked. This is just my random handling of whatever the trace back, or whatever exception that it threw, but you could handle it in any ways. You can throw a nice 500 error or anything of that sort in the previous layer that it's coming from. So that's about the quick demo. We have about 5 to 6 more minutes for some more questions. We could do that as well. Before that, I just wanted to share some details of consumption to how to be able to get to use this, right? So again, 3 primary value props: gain, visibility, and protection, as we saw in the demos and the discovery dashboards that we saw. Does not require any code changes. This makes it easier for security teams to be able to add this. Since it embeds itself as a Lambda layer, we could add this totally outside of the code itself. Currently supports Node.js and Python. As a promo, we have this for free until December 2021. And again, if you have, for example, any of our current or even new customers could try this for free until December 2021. So that's mostly what I had in terms of content. Feel free to reach out to me for questions. My email is here. It's basically my first name and last name at imperva.com. Happy to take them. You could also reach out to on the community channels for us to be able to respond to some of these questions if you have any as well. Looking forward to sharing access with more users to be able to get feedback. And also for you to get value from how the system is working as well. So that's mostly what I had in terms of content. I think we have about 4 more minutes for some more round of questions if we could.
Hey Rajab, I have one question. I have basically 3 questions we summarized. Do you have any documentation on this? Right now, I can't see on my current Privoti Rasp. I'm an old customer of Privoti, so my always says the Privoti, but on the Rasp manager, I can't see this on my Rasp manager. So how can I activate this? And that's all the 2 questions I have. And maybe what kind of support we require to onboard this application from your team.
Absolutely.
Raj, I would just add a tail end onto HJ's question, and that is, if you're a Flex Protect customer, how do you get started? That's maybe a good way to wrap up. Thanks.
For cool questions. So to answer that, HJ, and also to answer your follow-up, okay. So please do reach out to your existing account team, or just reach out to me directly as well on this email, and we can give you access to serverless. So the reason you don't see the serverless tab is because it requires a special kind of access. which we would enable it to you once we have your email, since you already watched the demo. And we will also share some of the onboarding documentation to be able to, guide you through onboarding your first serverless function from here. Those are two things that we could do. Reach out to me directly, or if you're working with any pre or post sales teams or customer success, reach out to them as well. They'll route the request to us to be able to give you the access to it. And to answer the follow-up, if you're a current FlexProtect Pro or App360 customer, so again, you do have free entitlement until December 2021. So you could continue to use this whether you're a current customer or otherwise. And then please do reach out to your existing account team to be able to get access to this as well. So so that's kind of the answer to that.
We do have one more question, Raj. Thanks for that, from Matt B. What is deployed in the CloudFormation setup? And we are 2 minutes under, so.
Great, okay. So what we're essentially doing is to create an IAM role on your behalf. If you can see the stack, I can go into some of what it's trying to do as well. And this is all visible to you when you're trying to create the CloudFormation setup as well. What we're essentially trying to do is create an IAM role that will give us read access to the Lambda function names across the catalog, and also to be able to write the Lambda layer from the UI, which is what gives you, for example, being able to attach Lambda layers or to enable configurations and stuff like that from here. So those are the two kind of accesses that we require. So this one basically creates that IAM role, the CloudFormation template.
We have one more question from Matt. I'll try to squeeze this one in. And Matt asks, he's asking about the overhead and run costs associated with any extra processing. Do you want to tackle that one?
Yeah, sure. So
Thanks, Matt.
there is an overhead when you're attaching a layer, very similar to like importing any other library. So there is an overhead associated with it. From our traditional RASP, we've seen that it is about like 2%. In terms of the CPU consumption and also in terms of throughput. So it's slightly higher when you're cold starting a Lambda function, but if a Lambda function is already warm, it's not significant at all. What I recommend is, again, this varies on a case-by-case basis. What I'm saying is based on some of our test functions, especially on Lambda. What I recommend is for you to be able to do this in, say, a development environment and do your benchmarking against some of the functions that work for you. So that's really the best answer. We can say what we do from our tests and what we've seen on benchmarks. So yeah, there is a performance impact, but it's not significant from what we've seen. And we've made sure the plugin is as light as possible to be able to facilitate that.
Thank you so much, Raj. And guests, thank you so much for your incredible questions. Everybody have an amazing day, amazing evening, and we'll see you at the next webinar. Thank you.
Thanks, everyone. Thanks, Kate.
Bye-bye.